Okay, so I'm going to be explaining to you thin film interference. Okay, to have thin film interference, we need a thin film, and it needs to cover some other material. In this case, I got water. There's a film of oil on it, and then air is always above the film. Okay, I also need to know the indexes of refraction of the materials. They'll give them to you. Okay, now let's explain what's happening. We have a light source above the film. Um, the ray hits the film, goes into the film, reflects off the bottom of the film, and comes back out. It also reflects off the top of the film. Okay, so I call these the two V's. The little v is that one. The big V is that one. Okay, the difference between the lengths of those two V's is this piece right here. That's the difference between the little v and the big V, the difference in length. We call that the path difference. Is equal to 2t because you have to go in and out. You have to go 1t, one thickness to get to the bottom, and then you have to come back out and do one thickness. So the the path length is 2t. Okay, now let's talk about phase shifts. Phase shifts is when a crest turns into a peak on reflection. I'm sorry, a crest turns into a trough, or a trough turns into a crest after reflection. So if I sent a little, um, if I sent a little crest down a jump rope, and someone's holding it firmly on one end, it's going to do a phase shift, and it's going to turn into a trough, and then continue going to the left. That's called a phase shift. 1/2 wavelength change in the shape of the wave. Okay, I will have no, if I don't have a phase shift because I'm holding it really loosely or I have that connected by a string to the ceiling, if I send a crest to the right, it will reflect as a crest to the left. No phase shift. Now, how do we know if there's a phase shift in this situation with the film? Okay, listen. If the ray goes from a lower end to a higher end medium, I mean, if it reflects off of a higher end medium, in this case, it goes from a lower to a higher, I will have a phase shift. Okay, so phase shifts only occur with reflection, not with refraction, only with reflection, bouncing off. So if it goes from a lower end to a higher end, we have a phase shift, and I will mark it with a little asterisk. Okay, how about when it flex off the bottom? Okay, so when it goes from a low end to a high end, it will do a phase. It When it goes from a low end to a high end, it will do a phase shift. But here it's going from a high end to a low end. So there's no phase shift in this case, and I will not put an asterisk there to indicate a phase shift. Okay, so um, if there was a phase shift, I'd have to indicate it. Now, I'm focusing on the phase shift on the bottom of the film when it reflects. That's the only one I really care about because you'll always have a phase shift coming from air into a higher end medium. Okay, so once you identify that asterisk, you use this equation. Um, use this equation to determine whether these waves right here interfere constructively, these reflected waves, whether they interfere constructively or destructively. Either they'll build each other up and be really bright, or they'll cancel each other out and you won't see them. Okay, so this equation relates, you will have constructive interference of those two waves when you have no phase shift at the bottom, when A in this equation is odd integers. So the smallest thickness you'll have is putting a 1 there, 1/4 of a wavelength of the light. And you'll have destructive interference if you put odd even integers there, the opposite. So 2/4 wavelengths, 2/4 wavelengths, 1/2 wavelength will give you destructive interference. That will be the thinnest thickness possible to do that. Okay. Now, if you did have a phase shift at the bottom, you didn't have it in this case. Up here, you only had one phase shift on the top. If you have a phase shift on the bottom, it's the same equation. It's the same equation as up here, you can see. And it's the same selection of what A would be, odd or even. But these guys flip. The CI and the, whether it's constructive or destructive interference, flips around. Okay? That phase shift really matters. Okay, so you can do that to use that to solve these problems. Okay, one more stipulation. That wavelength in that equation is really the wavelength in the film. I put a little prime number on it. I mean, I put that little symbol there to remind you of that. Okay, so you can't use this equation unless you're using the wavelength in the film, and the wavelength changes when it goes into a different medium. And so, how would you solve for that? It would be the wavelength in the air divided by the N of the film. So you'd have to fix that wavelength that's given from the air first before you use these equations. Okay? So there you go. That's it.